So what I thought we might do is talk a little bit about optimization, and to show how incredibly, not only how incredibly powerful it could be, but how easy the theoretical background is. You know, one of the things that we constantly struggle with, for those of us that do steel design, steel building, how many of us steel building design? Yeah? Yeah, okay. So one of the things that we constantly struggle with is to come up with a preliminary design of a structure. Because in order to analyze a structure, you have to first have some preliminary member sizes, right? Well, if you have a two-story frame, it's easy. You guess a few members, you do a little WL square over 8, peel over 2 here and there, get some stresses, and you have some preliminary sizes. But if you have a 50-story building, I mean, how do you come up with those preliminary sizes? Oh yes, if you're like me, who I used to be a consultant years ago, I've done a 50 or 60 buildings already. I've got a 50, 60-story building that already has been done. And tomorrow, the architect comes to me and say, hey, I've got this 25-story building, so what do? I go to my old drawings, pick up a building that had 100 stories, take the top 25 of them, cut them off and put them on the ground, and here's my preliminary design. Right? That's what we do, right? We always done that. Steal from the past. But you see, in this new way of working, you don't do that. The program, what you do to the program is you give them a series of member sizes and say, these are the member sizes I would probably like to use in this structure. Whatever they are, a set of wide flange sizes. And you assign that list to the various members. You might have a different list for columns, you might have a different list for beams, different list for braces. And the program will then automatically choose from that and give you a preliminary design which you can then optimize. And we'll show how that works. But you have no guessing involved anymore. You just choose those sizes and the program will come up. And if you want certain sizes to be the same, you can group the members, that all of the beams at this level, I would like the optimization to come up with the same size. You can do that. Okay, so that's one area. You've got your preliminary design done, you've got your final design optimized. Now, let's talk about deflection. So you've got the structure is now all preliminary designed and all final design. Now you apply your loading and your deflections are high. So what you do, you change some of the member sizes again and you run the structure. Especially if you're in an earthquake area, what does that do? If you have too much deflection, you stiffen up your structure, what does that do? It increases your earthquake loads, right? Because your time period is now shorter. You run the thing again, and your deflections are still higher. Because although it's stiff, you've got higher loads. So you end up in this vicious cycle that drives you nuts. Now you don't have to do that anymore. You have a deflection problem. Say your deflection is 3 inches. Or 2 inches, you want it to be 1 inch, you go in and say, this point I don't want deflecting more than 1 inch. The program will then go automatically into that list of members that you've chosen. It'll do a virtual work analysis and come up with a set of member sizes that when you apply the load to it, you've got all of your deflections within the same range that you want. Instantaneously, no guessing. So what I want to do is to show you how it's done, but more importantly, I want you to know how it's done. Not just the logistics of how the program works, but the theoretical background. Because it's incredible. It's so simple. I mean, I know all of us, when we went through college, we learned the virtual work method, right? And to me, it was always like virtual. I mean, so we've learned this thing, but how do we use this doggone thing? This is an actual practical application of the virtual work method. And it's mind-blowing. And when I first learned it, I saw this thing, my God, why didn't somebody do this thing 35 years ago? Here I'm sitting guessing all those member sizes. And everybody that uses that, I mean, I get phone calls from people, they're like, this is the best thing that, you know, that I have. One thing that alone makes ETABS worthwhile. And that's in steel design only. But you have the same concept that's applicable to shear walls and to concrete frames. And this new next release of ETABS, you would see it coming in there. But let's talk about that, because I really want to spend some time on this thing, because it's just something that is unique. And more importantly, for those of us that are in building design, whether steel, concrete, shear wall, this is something that you should really know. And